Welcome everyone. We're going to start the lessons this year with a week of review, and I've broken them down into topics. And the first topic I want to go over is called factoring. You've probably been factoring since freshman year. I don't think it hurts to go over it every single year. And so what I'm going to show you today is a couple methods that you've already seen. I'm going to encourage you that I think it'd be good to take notes because I'm going to assume going forward from this point that you all know how to factor. And so I'm just going to spend about 20 minutes showing you the different types of factoring that you should already know how to do. And I'll give you some examples. And again, I encourage you to write this down in your notebook so you have notes going forward. So to start with, I want to talk about what is factoring. Factoring is basically the opposite of multiplying. It's not dividing, it's just reversing the process. And so here's an example. If I ask someone to multiply the binomial 2x minus 3 times x plus 4, you might have done something like the distributive property, where you distribute 2x times x, you get 2x squared, 2x times 4, you get positive 8x, then you get negative 3x when you distribute negative 3, and then negative 12. Then we're going to combine like terms in the middle, the 8x and the minus 3x, so we finally get the product 2x squared plus 5x minus 12. That would be the answer. Well, notice on the right, then I ask you to do something called factoring. Factor 2x squared plus 5x minus 12. And what we should get is really what we started with on the left. This is a special type of factoring where you have a leading coefficient that's not equal to 1. And the way I like to teach students how to do this is called factoring by guessing and checking. So the way we would do this is we break the 2x squared down into 2x and x, because those are the two things. Then we multiply them together, we get 2x squared. And then negative 12 can be broken down into like negative 1 times 12, negative 3 times 4, or negative 2 times 6. The order doesn't matter. And then the way we solve this is we just guess and check. And so, for example, I know that I'm going to get a parenthesis and another parenthesis, and it has to start with 2x and x, because there's no other ways I can multiply two things and get 2x squared. What I don't know is which of these things on the right side, which of these it could be. I know from the left side the answer is negative 3 and positive 4, but let's say I didn't know that. Let's say I tried the wrong factors. And so what I'm going to do here in red is just kind of my trial and error. Let's say I'm going to try negative 3 and positive 4. Actually, sorry, let's say I'm going to try something wrong. Negative 2 and positive 6. Let's just try this. I know it's not going to work. So I do negative 2 and I do positive 6. I want to check. Is this going to be the right answer? Well, the way I check it is I multiply the middle, negative 2 times x, I get negative 2x. I multiply the outside, 2x times 6, and I get 12x. When I combine negative 2x and positive 12x, I get positive 10x. That does not match the 5x up here that it's supposed to be. So I know negative 2 and positive 6 don't work. So I could try something. I could try switching the order. Instead of doing negative 2 and positive 6, I could do negative 6 and then positive 2. That might have been right. It's not, but let's say it could have been. So I get negative 6x when I multiply in the middle. I get positive 4x when I multiply the outside. Negative 6 and positive 4 equal negative 2x. Again, this negative 2 right here does not match the 5x on the top. So I know that these are not the right answers. And then I could proceed to check other ones until I eventually get the right answer. Well, whenever I do eventually pick the right answer, I'm going to go ahead and do this at this moment. Let's say I were to pick negative 3 and positive 4. We know it's right because of what's on the left, but how would I check it? I would check the middle, negative 3 times x. I check the outside, 2x times 4, and I get positive 8x. Combining these together, I get positive 5x. This matches what I started with. So I know the answer is 2x minus 3 and x plus 4. So that would be the answer. 2x minus 3 and x plus 4. That's called factoring. So if you're asked to factor, you're asking for what polynomials would multiply together to give you the ultimate answer. So what we're going to do is we're just going to go through some different types of factoring that you've learned in the past. I'm going to try to make this video like a kind of goes over everything, but without being too long. And it's a good way to review so you're ready to go for college algebra or math analysis, whatever you want to call it. So first thing I want to review with you, and feel free to pause the video and write this in your notes. There are some formulas you can use when you're factoring either perfect squares or perfect cubes. And if you look at the formula a squared minus b squared, it equals a plus b times a minus b. So here's an example of something that you might see, like perfect squares are things that you can get a square root from. So if I were to, for example, ask someone to factor something like this, x squared minus 64. If you can recognize that 64 is a perfect square because you know the square root of 64 is 8, and you're being subtracted, you can go ahead and solve this pretty easily. You just take the square root of the first term and the second term, and you would get x, and then you'd get 8. You put that in a parenthesis, you start another parenthesis, you put x and you put 8, and then one of these is a plus and the other one's a minus. It has to be one's positive, one's negative, it doesn't matter the order. That's all you have to do to factor a difference of two squares. If I were to ask you to factor, for example, x squared plus 64, even though you could take the square root of 64, you can't factor this because it's a plus, it's not a minus. There is no way to factor this. This is prime, which means it cannot factor. And so if I were going to give you a question that you can't factor, you could just say the problem is prime, it can't be factored. Most of the time I'll give you problems that can be factored because I want to see you factor. All right, so then over here on the right side, what about perfect cubes? Well, if you know things that are perfect cubes, for example, 1 to the third power is 1, 2 to the third power is 8, and it's 2 times 2 times 2, 3 to the third power 27, 4 to the third power is 64, 5 to the third power equals 125, etc. So those are perfect cubes. So I'm going to do one example of this. I'm just trying to review the overall method of factoring. If you feel like you need more help on factoring perfect cubes, you can just search on YouTube, factoring perfect cubes, and you will find a bunch of videos. So I'm just going to go over one example for now. I'll do one with a sum. So for example, let me kind of make a spot here. Let's say I wanted you to factor this. 8x cubed plus 27y cubed. Okay? I can even make it have two variables. The first thing I would want to do is take the cube root of both terms. I know I can take the cube root of 8. I know I can take the cube root of 27, so I think I can factor this. As long as both exponents can be divided by 3, I can do this. And so if I were to do that, the cube root of 8 is 2. The cube root of x cubed, I take 3 divided by 3, I just get x. Here the cube root of 27 is 3, and the cube root of y to the third power is y. That's how I factor them with the cube root. And so where we're at with this is that this part right here is matching the a plus b in the formula. And so if I look at the formula, I see a plus sign. So I'm going to put a plus sign right here. 2x plus 3y. What I need to do to finish the answer, you see this part over here that's a trinomial? I need to write that answer over here on the right side. And so I'm going to do this in my head. If you guys are in math analysis, you're going to be able to do a lot of math in your head. This is really the a plus b when you see a plus b. So I want to do a squared minus ab plus b squared. Again, I'm just getting this directly from up there. And so all I'm going to do is I'm going to go ahead and just plug this into my head. If a is 2x, and I'm saying what's a squared? 2x times 2x is 4x squared. Minus, switch the sign, a times b. Well, 2x times 3y is 6xy. Then a plus, and then it's b squared. So 3y times 3y is 9y squared. So I gave you a little bit of extra writing here, but this is the factors that you'd write as your answer. So that's factoring a sum or difference of perfect cubes. Again, if you need more practice, you know who you are. Look online at YouTube and search some videos, and you'll find lots of examples. Also, come to office hours or ask me for extra help. I'll be happy to go over extra examples with you. Okay, moving on. Now this is actually the easiest kind of factoring. I'm going to go through all the different kinds. We're going to have factoring by grouping, factoring out the GCF, factoring trinomials, factoring special case trinomials, and you'll see what I mean. So number one, the greatest common factor is what you look for between the two terms. What do they have in common? What could you divide from 3x squared and 6x? And so I'm going to say the GCF between 3 and 6 is just 3. I can divide 6 and 3 both by 3. And then I look for what variables they have in common. They both have at least an x, so I can take out an x. They don't both have any y's in common. We see 3xy squared, but the 6x doesn't have any y terms. So all I can take out is 3x. So I can write 3x, and then I'm going to do basically the distributive property backwards. I'm going to divide 3x away and see whatever I have left. So 3x would go away, I just have y squared. And then plus 6x divided by 3x is just 2. That's the answer. So pretty easy. I think you guys have been doing that since junior high. We're going to keep going. Number 2, I just put extra variables, but it's the same thing. The GCF is they have x, y, and z. They all have all 3 variables, but there isn't more than one of each variable in both terms. Like the first term has 2 x's, 2 y's, and 2 z's, but the right side just has one of each. So the greatest common factor will just be the lowest number, x, y, z. And so if you take this away, if you divide x squared, y squared, z squared by x, y, z, you get left with 1x, 1y, and 1z. Subtract 1 from each exponent. Now don't forget this. On the right side, if you take x, y, z and you divide it by x, y, z, everything cancels, but you can't just leave it blank. You have to put something there. If you take something and divide it by itself, you get 1. Think of like, what's 2 divided by 2? It's 1. So x, y, z divided by x, y, z is 1. That's it. Factoring out the greatest common factor. Okay, so we're going to move on now. That was the GCF, greatest common factor. Another type of factoring that you need to know how to do is called factoring by grouping. And I want you to know, when do you usually factor by grouping? We factor by grouping whenever we normally see 4 terms that don't have a greatest common factor. So typically this is when there are 4 terms. Okay. Almost always when you see 4 terms, if you can't find a common factor, you're going to factor by grouping. And again, this isn't exactly a lesson like you're seeing it for the first time. This is more of a review. So I'm just going to go ahead and show you how we'd factor both problems. So if I were going to do number 3, I'd say, well, if I'm going to group this, grouping just means parentheses. I'm going to put parentheses around the first 2 terms and look for a GCF. I can divide by 2, because 4 and 2 can be divided by 2, and I can divide by c, because they both have the variable c. If I divide by 2c, I get 2a, plus if I divide by 2c, I get b left over. And so that's what I did. I took out the greatest common factor of the first 2 terms. On the right side, I can go ahead and look for a greatest common factor. Now there is no number, but if you notice they're both negative, I can take out a negative number. So I'm going to do negative 1. I don't have to write the 1, it's optional, but I can do negative 1 or just negative, and then the variable d. So negative 1d or just d, and what I'm left with is 2a plus b, because you're going to switch both signs to positive. I want you to notice that this and this, these must match. Okay, so if they don't, you're doing something wrong. Okay, but they always will if you're factoring by grouping. So then what I do at the end is I make a parenthesis and another parenthesis to be my answer. The 2 that match are going to get put right here. So 2a plus b. If I were to factor this out from both of these, what I'd be left with is 2c minus 1d. Or you can just say 2c minus d. And that's it. So that's how you factor by grouping. If you did take time to distribute, you don't have to do this. You would find if you distribute, you would get the original polynomial back. On the right side, let's go ahead and do this one. If you want to pause the video and try it yourself, go ahead and do that. I'm going to go ahead and explain it. Feel free to pause the video and try it before I go over the answer if you'd like to make sure you know how to do it. So on the right side, we're going to do the same thing. We see 4 terms. We're going to factor by grouping. I'm going to take out the greatest common factor, x squared. I'm left with 3x plus 2. I already know that this needs to be 3x plus 2. Remember, this has to match the first parenthesis. So what would you divide from negative 12x minus 8 to leave you with positive 3x plus 2? And the answer would be negative 4. And so, just like before, the 3x plus 2, the one they have in common, goes here, and then the x squared and the minus 4 gets brought together into its own factor. Okay? If you did that part correctly, you're right, this is correct. But there is one other thing we can do. This can be factored again. You always want to factor completely. So if you can factor one of your answers, you need to do it. Do you recognize that x squared minus 4 is a difference of perfect squares? Go back to our second slide. We can factor that again by taking the square root of x squared. We get x, and the square root of 4 is 2. Remember that one of these is a plus, one of them is a minus. And then we put 3x plus 2 at the end. So what we just did is called you factor completely. Okay? Means you factor everything until you can't factor anymore. All right, I'm going to keep going with the video. Again, if you need more practice, please look online for videos. Please let me know. I'll be happy to help you. So today's lesson, we're going to go over factoring by grouping, and next, factoring trinomials. When I say it has a leading coefficient of 1, that means, for example, you could put a 1 in front of the x squared. It doesn't mean anything different. They have no numbers in front of x squared. And so that doesn't mean anything other than the fact that this factoring is a lot easier. So the way we factor all these is we start with 2 parentheses. They both start with x in this case because x times x is x squared. And then we come up with negative 10. To find numbers that multiply to be negative 10, one's positive, one's negative, we try to find out which ones would add together to equal positive 3. So for example, I could do negative 1 and 10, or I could do negative 2 and 5. The ones that would multiply together to equal negative 10, but add together to equal positive 3 are the ones we want. In this case, I know the answer is negative 2 and positive 5. X minus 2, x plus 5, those are the factors. And you can do that in all of these problems that have a leading coefficient of 1. So for example, on number 6, I'm going to go ahead and start with 2 different parentheses. X times x is x squared. I want to find numbers that multiply to be positive 20 that combine to be negative 12. Now, whenever this number is positive, you can get that with a positive number times a positive number, or a negative number times a negative number. So I want you to think about that. Numbers that multiply to be 20 are 1 and 20, 2 and 10, or 4 and 5. Now, none of those would add up to equal negative 12. The only way I can make it add up to negative 12 is if I did a negative times a negative. So they're both negative. Negative 1 times negative 20 is still positive 20, but it gives me a negative middle number. So what I'm going to do is I'm going to go ahead and have you look at this. You shouldn't need to try this. You can just pick the answer or do this in your head. But I'm just trying to show the work to make sure it makes sense. Negative 2 and negative 10 are the ones I want because they add up to negative 12. So x minus 2 and x minus 10. All right, so now we're going to keep going to number 7. Again, I'm trying not to take too much of your time through this video, but hopefully it's a nice review. If you look at number 7, I want you to notice there's 2 variables. One's an x and one's a y. You might say, wait a minute, I don't know if I can do this. It's the same thing as number 5 or number 6. All you have to do is put a y at the end. And so let me show you what this will look like. You're going to start both with an x, and I'm going to tell you you're just going to end with a y here at the end. Everything else is the same. Numbers that multiply to be 21 that add up to negative 10 are what you want. They're both going to be negative, just like number 6. It'll be negative 1 times negative 21, negative 3 times negative 7. I don't know any other ways to get to be negative 21. The ones that add up to be negative 10 are negative 3 and negative 7. Let me put those here. The only thing we're going to do to make sure we get the y squared at the end is put a y at the end. So it's x minus 3y, x minus 7y. I should mention that the order doesn't matter what you write when you factor. I just like to put the small number first, but you don't have to do that. So we're just factoring. You're trying to come up with parentheses that multiply together to equal the first polynomial. And I wanted to show you one that might be a little bit strange for some of you. If you look at number 8, take a look at this. It's to the 4th power and then to the 2nd power. I know that might look weird, but here's what you can do. Just look at what I'm about to do. Instead of m times m to be m squared, I can make it to the 4th power if I did m squared times m squared. You could just start with a higher power exponent. It is totally fine to do this. So m squared times m squared is what you could do. And the same thing as before, numbers that multiply to be 16, 1 and 16, 2 and 8, or 4 and 4. Okay? Well, which ones multiply to be 16 that add up to be 8? It looks like 4 and 4, so it's just m squared plus 4, m squared plus 4. That's it. Some of you might be thinking, wait a minute, could I factor that again? Isn't m squared a perfect square? Isn't 4 a perfect square? Yes, it is, but did you see the middle sign as a plus? You could only factor this a second time if it was m squared minus 4, only with the subtraction, a difference of 2 squares. This is a perfect answer. You also could write this, because the factors are identical, as m squared plus 4, the quantity squared. That is also correct. It's up to you which way you'd like to write it. Okay, so that's how you can factor with a leading coefficient of 1. It's not really that difficult. The ones that are difficult are when it's a leading coefficient, some other number besides 1. If there's something in front of x squared, like you saw in our earlier example. So let me go ahead and show you a couple examples of that. I'm going to show it with the method called just guess and check. It's a lot quicker than the other method. Well, there is another method for this, and if you don't really like guess and check, I'd be happy to show you another method. But this is a faster method. So what happens is a leading coefficient that's not equal to 1. This number 2 right here is not 1. So to break 2x squared apart, 2x times x is 2x squared. Okay? So I know when I have my factors, there's no other way to get 2x squared. It's going to start with 2x, the other one's going to start with x. Over here to be negative 6, to get a negative number, I guess I should erase this, hang on. Okay, to get negative 6, you need a positive and a negative. So I could do like positive 1 and negative 6, positive 2 times negative 3. I don't know where exactly the pluses or minuses are at this point. I just know that those are my options. And so I'm going to guess and check. And I know that it doesn't sound like it's fun, but you just need to be able to do it. Okay. And so I've shown you some examples of how to guess the wrong answers. So if I were to guess the right answers, let's suppose I were to guess that it is 2 and negative 3. So for example, I'm going to try positive 2, negative 3. Is this the right answer? Well, let's do the checking. This gives me 2x if I multiply the middle. It gives me negative 6x if I multiply the outside. I get negative 4x. That's not the same thing as negative 1 or negative x. But that doesn't mean I picked the wrong numbers. What could have happened is I picked the wrong order of the numbers. So let me go back. Let's say I think it's 2 and negative 3, or let's say it's 2 and 3, maybe it's different numbers. Let me try this. I'm going to try negative 3 and positive 2. Maybe it's those numbers in a different order. And so I'm going to try the middle here, I get negative 3x. I'm going to try the outside here, I get 4x. Now I get 1x. Actually, that's right. This is a 1, but it's the wrong sign. I wanted to say negative 1x, but there's a real easy change. All you have to do, if you have the right number and the wrong sign, is to switch these two signs. If I made this say positive 3, and I made this one right here say negative 2, then I'm going to get positive 3x, negative 4x, which combines to negative 1x. That matches, this right here matches right here. Okay, we know it's right. So the answer is 2x plus 3 and x minus 2. Okay, that's your factors. If you like keeping your paper neat, you might want to use scratch paper if you're ever factoring, because you don't have to always do all the work on the same page. Okay, over here on the right, I have another example. This one's a little bit more difficult, and the reason why it's more difficult is if you think of numbers that multiply to equal 15, it's not just 15 times 1, or 15a times a in this case. Isn't it also possible to be 5a times 3a? And so in something like this, you don't know what the order is. You don't know which one to put first. We have to, again, guess and check. My suggestion is to guess and check the numbers that are kind of closer together usually, like 5a and 3a. But it's really up to you. I can't tell you what's always going to be right, because there isn't like what's always right or what's always wrong. To equal 4, I can do -1 and 4, or -2 and 2. If you guys want to know a hint, I'm going to go ahead and give you a hint to make this easier for you. Okay, a little bit of tips. Because the middle is an odd number, okay, you can't use two even numbers. Okay, you can't use two even numbers to get an odd number in the middle. There's no way. You will never be able to add or subtract even numbers and get an odd number. So that actually helps you. 2 and 2 will not work because I'm not going to end up being able to get an odd number out of those. I'll say 4 and 5 middle term. Like, which by the way was 17a. Okay. So, I know it's not 2 and -2. I think I covered up the negative sign. I know it has to be -1 and 4. So, let's go ahead and say it's that. I'm going to try the 5a and the 3a as my terms. I can put -1, +4. Let's see if it works. -3a. Here I get 20a. That looks like we lucked out. We get 17a. That's the answer. So it's just 5a minus 1, 3a plus 4. This is probably the hardest type of factoring that you're going to have to do. If you can master this type of factoring, you're going to set yourself up to have an easy time in any higher level college math class. And so that's why I feel like it's important to go over factoring, just to make sure everyone's on the same page. I want to end with one last slide. Thank you for watching this far. The last slide I'm going to put is just factoring problems that could be factored more than once. You don't always know if factoring problems could be factored more than once until you start them. And so always factor completely. That means if you can factor it 2 times, factor it twice. If you can factor it 3 times, factor it 3 times. And so, again, if you want to pause the video and you want to try these, go ahead. I'm going to go ahead and just explain them so we can finish up. Number 11, I don't look for a common factor because it doesn't really have any, but I do see it has 4 terms. So that tells me I'm going to factor this by grouping. And so I'm going to factor the first 2 terms. What's the greatest common factor? X squared. I'm left with x minus 5. Okay. In fact, if I know that x minus 5 is going to be that parenthesis, I already know that this one should be x minus 5. I need to think if I divide it by 4, I would get negative x plus 5. I should divide by -4. That leaves me with x minus 5. And so then just like before, I bring down the first 2 factors. I get x squared minus 4 times x minus 5. You did the factoring by grouping correctly, but remember, this is not finished. Okay? I'm going to make a little annotation here. Can factor again. Okay? It's up to you to know when you can factor things again. So the more practice you get, the better. It's a difference of 2 squares. X plus 2 times x minus 2 are the factors. And then you bring down x minus 5. So that's factoring completely. Make sure you do that. A lot of college professors will not give you credit if you don't factor things completely. Number 12. It looks kind of weird, but we can take out a greatest common factor. So remember that what's called the GCF. They both can divide by 2, and they both have at least 1x. So I divide by 2x. I get x to the 4th power minus 16. Okay? Don't stop. Remember I said Always factor completely. Can you factor x to the fourth power minus 16? It's a perfect square. It's a difference of two perfect squares. So the answer is yes. You can take the square root of x to the fourth power and the square root of x to the 16th power. The number 16, not the 16th power. It's been a long day. So it's 2x, and then the square root of x to the fourth power is x squared. The square root of 16 is 4. Remember, we write this twice. Remember, one of these is plus, one of these is minus. So we did it. We factored it twice. We did factoring completely, didn't we? Except not yet. Remember, you can factor a difference of two squares. When you have a difference, when you subtract, you can factor it again. Okay? Not this one. This one right here, a sum is prime. So a sum of two perfect squares, you can't factor it again, but this one you can. And so just to get down to the final answer, you're going to write 2x, you're going to write x squared plus 4, and finally you break the x squared minus 4 down into x plus 2, x minus 2. We end up with a lot of different factors. And so again, that's factoring completely. So when you're all done, when you're factoring completely, you get things that you factored all the way down so they cannot be factored anymore. So again, I hope this was a nice review. If you need any help, please stop by and see Mr. Norlian on the Google Meets. Please send me an email. Check YouTube videos for the title of this type of factoring. And again, hopefully this was helpful. Thank you.